Thank you, Johannes. So, as Claire already mentioned, yesterday we had a nice big time stretch of roughly 4 hours to discuss emissions variability modeling in different projects. And we had well, as a backbone, we had contributions from the CAMS 261 emissions project, from 240, so the regional air quality modeling, and 235, the global modeling project. So emissions variability modeling, why did we want to discuss it? Because it's used to generate emissions that become part of the inventory. For example, the shipping emission data that we have shown you are done with an emission model. But it's also really being used for temporal distribution of emission within the year. So if we get reported data for a whole year, then you still want to know when. We also want to know where, but we also want to know when it is emitted. And for that, we also often use a model to, to simulate the activity that is releasing those emissions. However, you can also use it to forecast or calculate emissions using activity data or proxies that are very similar to your activity, or use meteorological data, because you know that the activity is actually triggered by the meteorology, like, for example, you heat your house when it's cold. So we use that to support inventories and bring it into the inventories, but also directly in the models. And so how is this are we all moving in the same direction? What can we learn from each other? And what is the future? That was more or less what we wanted to discuss. For that, we had 4 contributions. So the CAMS emissions team had a presentation. We had a presentation by Augustin Colette on behalf of the CAMS 240, so more on the dynamic emissions modeling, and especially the heating degree day approach in the regional models. There was a related contribution, which was presented by Mikhail Soviev from FMI on an alternative way to do that. And then there was Vincent and Samuel presented the emission testing done in the CAMS 235. The presentations of those, I think we will make those available, right? So what I will do, I will just give you a few images from those presentations, but I don't go into detail. But I think if you're related to those projects or this kind of work field, it's really interesting to scroll through those presentations and pick up some things. So this was shown by Mark, and it's just to prove again that we can really model the release from, or actually the energy demand from households. So what you see in blue is the model, and in orange are the real data from, for example, a gas distribution company. And it's driven by meteorology, and we can really capture that very well. Then Augustin showed that to test this, they actually have a real setup in the CAMS 240 project, where they did, with 7 models, tested the implementation of that heating degree day approach, as we always call it, for the emission timing in the models. And the short message, the model performance scores really improve a lot. However, it's also very interesting to also look at what does not go so well. So what are because usually we can learn a lot more from that. That's in the next slide. And also here you already see at the bottom, so FMI, CLAM proposed an alternative, and I'll show one slide on that. So this is just to stress again that, and it's a nice thing, you have an ensemble, you have different models, but then the outcome overall, it improves, but when you start to look into the different models, you still see relative differences between those models, and some things that need to really be digged into deeper. Why is that? And we will learn more from that. So it's work in progress, and there is, as I said, there are these presentations where you can find a little bit more detail on that. Already said, so Miguel presented the work done at FMI, which has a slightly different approach, where they looked at a much longer time series and giving a little bit more freedom to how you predict it. And I just want to say that looked really nice, where you compared the 2016 as a reference year to what you forecasted for 2017 and then later what was reported, it looked really nicely in line. So that's another interesting approach. And so there is a lot of progress, I think, in this heating degree day approach. But that's not the only thing. And I think this was also a very nice slide shown by Mark, that we also have other sectors like road transport where there could be a real impact of meteorology. For example, here you see the impact of low temperatures on the NOx emission for diesel engines. So for gasoline, it's a flat, there is no impact, but this suggests that if you have very low temperatures, there is really an increase in the NOx emissions from diesel engines. And this is typically something like the heating degree day approach. This we could bring into the models and try to better represent, the observations that we have in different cities. So this might be something as a next target for us. Then on the 2020, so the year, the COVID emissions, we've already seen various cases where different approaches were done to capture that impact of the COVID reduction on emissions. And this is just for one sector. And I only show this because it gives a large mix. So you see that we now have the reported data. We have different ways to estimate those activities and thereby the emissions. But the signals are not all the same. So we really want to use the time now to analyze. In a way, nobody wanted COVID, but for this kind of things, it is of course a beautiful experiment, and we should profit from what we can learn from all this. So that was also discussed. Another one on when it is about using online modeling or even incorporation into the models, which is driven by meteorology, are the biogenic VOC emissions. So this is another one that is really on the list, and we already decided that in the next month there will be a meeting with the CAMS 235 and CAMS 261 team to make some first discussions and ideas what could be the next steps, and we will follow that up across the year, and I think maybe next year we can also tell more about how that is going. Claire presented some work on the differences between, for example, as was already mentioned, EDGAR version 6 is now available. It has some discrepancies. There were some issues, especially around SO2 emissions. So we also used the time yesterday to actually discuss what would be the best way forward, how is the timing, when are the products from CAMS 261 needed, do we have the time to incorporate this, or should we postpone that? This is really an interaction that is necessary between the different projects. So it was also good to use the time for that. And then finally, there was, I think, also very inspiring, the evaluations done in the global model systems, and they also give us, and I like this slide where you see that we have different CAMS emission products, so a version 4, a version 5, and a special one where we included a more specific inventory for China, which then in the system much nicer follows the observation. So from that we can also learn a lot, and we can make some choices on how should we go about this in the future. So these were the kind of things that were discussed. Vincent also showed, maybe because we see that we need to interact more, and we need to do that on a shorter time scale than just following the full project. So we have now a project, a contract for 3 years, do the work, and then evaluate. We should really try to do that more within the projects, and this is just a first idea of how we could do that. But we need to discuss that further, because nothing is ever easy. We all also have all our deliverables and plans, etc. So, but I think this is the way forward. So some conclusions. Yes, the heating degree day approach is a very nice test case. There's more information on it from all the different projects if you want more. Activity data modeling is also done in the carbon monitor, for example, really helped us to have COVID year emissions and large disruptions, like for example in aviation are really well covered. But various approaches disagree when you start to look at sectors that are not as clear. For example, industry or even road transport. We see variations that we want to analyze further. So there's really a community effort needed to understand that. Biogenic VOCs, I touched upon that. It's really a candidate for having more directly driven in the models. But the test and the feedback from the models on resulting emission products is really useful for us to give guidance on what to use. For example, that case of China that I showed you. And the test on trends by the emission data will be very useful, also for preparing for a next reanalysis. Interpretation of the model observation discrepancies is often challenging because there's uncertainties in the emissions, there's uncertainty in the emission processes and even in the transport. So the design of such tests, it would be really good if we work on that together. And another thing that we can really do is together identify low-hanging fruit. So what is not very demanding in the models, what is something that we could really deliver from the inventories, and examples could be specific, relatively crude temporal profiles, for example, incorporating holiday seasons, which are now not properly in the temporal profiles. Reporting emissions as an output of the CAMS production services and their intercomparison could really help identifying issues. And yeah, I think everybody agreed on that, and the most important message was that we really need to strengthen the interaction and the exchange in CAMS2, and we really have time now. The projects have just started, we have 3 years ahead of us, so we can really plan it. So we need to plan meetings on a regular basis, and we will really learn a lot from that, and it's inspiring for all. It's nice to see your products being used, it's good to get feedback. We enjoyed it. It was a very good discussion yesterday. Thank you.
Thank you, Hugo. I think this was a very nice summary of our discussion yesterday. Maybe we just move on to, or if there are specific questions, yes, please.
I don't have a microphone. Well, I have one, but I can't give it to you.
Thank you. It's been really interesting presentations about all the emissions. I'm just wondering what the plans are in terms of making these emissions data available to CAMS users. So I know that the global data sets are available through the ECHAD database, and I think the fluxes are available through the ADS. Are there plans to make the regional emissions available through the ADS? And if
yes,
so,
absolutely.
Is there a timescale for that?
I don't know actually if there's a real time scale, though. Huh? For the microphone. Okay, sorry. Yeah, so we have interaction on that, and they're supposed to become all available on the EDS. But if you want access now, they are already available, of course. So they're partly through ECHAD also, but also directly through us. We can give you an FTP link where you can download them. So we're moving into the atmospheric data store, but the focus was first on having the global data available, because that's also used in the IFS, and so that was the reason.
They all will be made available. Yeah. That's our aspiration, yes. Yeah.
But contact us.
Yeah. Okay. You had a...
Yeah, just to make the link with users. We have a partnership with the European Investment Bank, and based on a discussion which we had early February, they're very interested in the CAMS emission products, especially as a reference data set. When they do investments all over the world, they want to see what's the impact on emissions. And to verify this with a standard emission data set, they want to see what can we use and how can CAMS provide support on this. So it's a very interesting entity who, I don't know if it's, how do you call it, a VIP user, but it's a very interesting user. So there is certainly an uptake on
I would be
emissions.
happy to discuss that, because I think there's good possibilities there.
Yeah, thank you.